Okay. We're going to do we rush things a little bit at the end. So a lot of people had a lot of questions. So now it's time to ask those questions and to clarify. And then we're going to do a little bit of hands-on and practical uh, cases and stuff. Yes.
Hi, I'm Luca. I
Hi,
have two
Luca.
questions. One is primitives in complex structures. Like, do you need to compact them manually or is it compacted?
Pardon me
Like,
again?
if we have structures complex, like
Struct.
struct or enum, does it compact primitive types inside of it or not?
Does it?
Compact the ints or something like that.
You understand the question?
So you're asking if compact can be a primitive type as well, basically.
So when you use it
Yeah.
in the examples, the types inside of the enum, like you have uint 64, it isn't compact in the example. So do you
Yeah,
compact
yeah,
it?
yeah, now I understand. Yeah. Compact itself is another primitive. It's like another size of
So-
integer, right? So
Okay, you can compact it inside
exactly,
of it.
it,
Okay, okay.
exactly. It can the number can
So
or cannot be
a complex type is a type that can reference any other type, including complex types.
Okay,
So
okay.
we
I
did-
understand now. Yeah, yeah. Thank you.
Okay.
And for the second, the size of vector. What's the maximum size of vector?
Oh, good question.
Yeah, because when you showed it, it was like size of the compact, right? And 67 then, is it the maximum size of vector or you can
So
like
let's think
extend it?
about it, right? Like a vector basically is a compact value first letting us know the length of that type,
Okay.
and then we're going to keep applying the codec of that vector over and over n times that the compact value set.
So
Therefore,
first,
the max value of compact is going to be the max value of a vector.
okay, so first value is compacted, then okay.
Yeah, yeah. We're like, I'm pretty sure that like when we explain vectors, um, it's a compact encoded value that takes the number of instances, right?
Okay, okay.
So
So the first one is compacted, then okay.
first we start doing a compact, and this is going to tell us how many instances of whichever it is that this kind of vector is, and then we're going to apply that codec, like that decoder or encoder, depending on which operation we're doing, that number of times.
Okay, okay. Thank you.
Yeah. Another question or?
My name is Gil. I have several questions. One first question is actually a follow-up to the vector question. So if I have a vector of U8, it basically means that the maximal size of my vector is 256. I cannot have any bigger vector than that.
What? Why is that?
Because if my first value is the length of the vector,
But
then I
the
have-
first, like the vector, a vector starts with a compact,
I see. Okay.
not with a U8. That's like the U8. It's for variance and enums. The vector, like it's compact. That denotes the size. That's why compact is very useful because like most of the times it's not going to be a long. There are not going to be many elements, and then compact is going to save us a lot of memory. But if it's very large, then we're going to utilize the bytes.
Okay. Another question is about compact. You said that we don't waste any bytes at all, but
I didn't say we don't waste bytes at all. Actually, I said that we are wasting bytes because there are some permutations that are not possible. Remember, like there are certain permutations that are impossible. Like they cannot be translated into a valid compact value. Therefore, there are some instances where we are wasting, if you want, but it's still a lot more performant than always using a humongous amount of bytes.
I see. But have two more questions. One question is why don't we use like some other standard like protobuf, for
Why
example?
what?
why won't we use other standard like protobuf, for example?
Why are we not using protobufs?
Yes.
Ah, okay. Uh, for a number of reasons that it will take me a while to explain, but like, uh, protobuf was designed for, it's like,
We
I don't
can.
know. Go ask Gavin. I don't know. Like, but
We can also take it offline. I'm just curious because protobuf is widely used, right? Like you can see protobuf used somewhere else, and I think it's natural to raise this question: why don't we use standard? Um, but we can also discuss it later if you feel like it's not the right place.
so protobuf is a good standard, if I recall correctly, created by Google, and it's used mostly for I I don't uh, let's assume that the research was done in it, and it was determined that for the runtime, scale was better for the performance of the WASM.
Okay. And is there any importance for the
The
little?
child of what? Sorry. Go ahead. Like, maybe Sean can answer that one. But I mean, like, I don't see the.
Yeah, so the last question is why do we use little endian compared to big one? Is there any specific reason for that? Or?
We explained many times, I think, why we use little endian.
Okay.
But like, I can recap again. Like, WASM by default uses little endian. There are many advantages when it comes to casting values by using little endian because we don't need to copy the bytes again. I think we have covered why little endian is superior for the stuff that we're doing. Yeah.
Okay, so I'll talk about why not X or any other kind of thing. Well, one big thing is that we're building a protocol, right? And so if we depend on an encoding format by a third party and they change their format or break it or whatever, it could break the blockchain, right? Obviously, you need a system that is always backwards compatible or that maintains the history of the chain, etc. Another thing is Protobuf is a much bigger project. So Protobuf, as I understand, is not just about this one compact encoding, but it allows for like lots of different encoding formats, lots of different like things you can build on top of it. Scale is designed to be very minimal and small. It's designed to be like work really well with Rust specifically. So like you can just add these simple encode decode derive macros, and it just does it automatically for you. It has a lot of types and a lot of information specific for blockchain. So like things like max encoded length, things like type info, metadata, all that kind of stuff is automatically generated around scale as well. And then it also use STD, right? So one of the things is when you build it within WASM, we assume a no STD environment, and scale doesn't need that, whereas perhaps parts of Protobuf does. So anyway, this is the most minimal, most efficient, fast version of this, and that's pretty much all you need there, right? Again, a really big one is that you don't want, you're designing a protocol to be dependent on some third party who can change the spec anytime, who doesn't care about breaking you, who doesn't do whatever, right? Like you need to sometimes control the protocol itself and design a system.
Yeah,
More questions?
yeah, there was a guy with the mic already.
Hello. Yeah, hi, I'm Cal. I wanted to ask about Boolean representation. So right now we're anyways wasting 7 bits for every Boolean that we store, right? Since we're basically representing it as a U8. But why don't we change the representation to something alternate? So suppose you represent the first 3 bits of your U8 to be the number of Booleans. So suppose you have 4 Booleans right after each other. So you have Boolean, 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 Boolean. So right now we represent it using 32 bits, out of which 28 bits are wasted. If we had an alternate representation where the first 3 bits were the number of Booleans, so in this case, you'd say 4 in those 3 bits, and then the remaining number of bits can store up to 5 Boolean bits itself. So that way you'd be able to store 5 Booleans in one U8 rather than have 4 U8s itself, right? So why do we use this representation?
Okay, so long story short, right? Like, as we explained before, like the minimum unit is a byte, right? So basically, what you're suggesting here is, okay, this is a waste because like there are going to be times that we're going to want to express like many booleans in a row, but that is actually not true. Because when that happens, basically what you're doing is it's a bit mask, right? So if you need a bit mask, you just use an array of U8 or a variant or a vector of U8 or whatever it is, and then just use that as a bit mask, and you're done. But there are times that you need to have a genuine like, Boolean, and you need to convey that to your user, like this is a Boolean. And the only way to generalize that, because what you're suggesting is like, oh, we're going to be doing beatboxing, and then it becomes pretty much impossible. Like it's very unperformant on the long run to always keep track of like, oh, at which beat was the last time. Like it's very inefficient in the long run. But like what I'm trying to say is like obviously there are many situations well, not many, but there are some situations in Polkadot that actually you want to have bitmap, right? Like you wanna use the try codec uses bitmap. They are also being used for core time. For like there are a few options, but you don't know you don't need to make these a first class citizen of the type system for the few exceptions you have when you have one of them, like at the application level, you already know that you are describing is byte, but you're going to treat it as a bit mask in your logic. In the same way that sometimes you describe something as a number, but you know that this number is going to be split in two parts independently, because what I'm saying is that belongs into the application level logic, and you don't need to make it the first class citizen of the encoding logic. Does that answer the question? No? Yeah? Okay.
There are no strings types in scale.
Okay, good question. Yes and no. So this is another case, right? Like, how do we express a string? Or you could also ask, like, how do we express, like, a string is basically a vector of U8, right? And then in your application logic, since you know that this vector of U8, this byte, is meant to represent a string, then you interpret it as a string. Like, scale itself doesn't have the string as a first class citizen, because that is something that is deferred to the application logic. Does that make sense? So you in your app logic know that this needs to be treated as a string. But from the point of view of scale, it's a vector of bytes. So it will start with a compact value that's going to tell you how many bytes you have, and then it's a block of binary data, and then you're going to probably encode it decode it or interpret it, probably UTF-8 or whatever you want. But that's for the app level logic, yes. But just by the way, like this also applies to things like we need to keep in mind that when you say data structure, right? Like a set or not that complex, but like or a map or whatever. For scale, the way to do it is to interpret it as or either a vector of tuples. You need to find what works best for you, and then at the app level, you convert it in what's best in what's more convenient. Does that make sense?
I know you are, but wait till the mic comes to you.
Means development becomes a little bit difficult. With Vec UI, we cannot do string manipulation or something. It's get a bit difficult. While in other smart contract, strings are available as a first class.
Sorry, go again.
In other smart contracts like Solana, string is available as a first class.
Okay.
Yeah, that's what means. Development becomes a little bit difficult when we do back U8. String manipulation becomes a bit difficult.
I don't see why that's true, but I guess that's like what like I don't. So we're explaining scale here. Like we're explaining like later we're going to learn more. We're going to explain the metadata. We're going to explain how there are frameworks that actually translate things to scale and make things easier for us. Like we're explaining scale, right? Like that there are other layers on top of it that facilitate you in your programming language using strings like normal, and then the framework handling everything for you. Like Frame does that. Papi does that. Like at the application, like when developers are working, they can work with strings normally. They don't need to work. But that is going to be translated when it comes to scale to a vector of U8, right? That doesn't mean that just because it's not defined at the scale layer doesn't mean that there cannot be another layer on top that creates a nice developer experience that allows you to work with all these data structures or with these types or with this vector or whatever. I don't know if this makes sense.
The guy in front with the mic. Yeah.
So I have two questions. One is that you mentioned that scale is not self-descriptive, right? Is that because we want to save space so that we don't actually attach descriptions? Is that the reason?
Well, one of them.
Okay. Are there any other particular reasons for doing that? Like apart from this thing, I'm just curious. Yeah.
Well, the thing is that as we will learn in a session later today, it is actually possible to have a convention that, in fact, is scale encoded, and this convention is in the metadata, and this lets us know how everything is described in the runtime, right? So it's like since we can solve it in a very particular way, then that allows us to have the scale encoded data super efficient, right? Because we can put the definitions somewhere else, and then we can make sense of everything, right? So that
makes sense.
My second, we'll learn more about that later. But yes, like what we don't want to have is like the same information repeated over and over and over just for
My second question is, I noticed in the docs for options rule that it's
that is not the case anymore. Like those docs are updated. Yeah, you realize that there is an edge case for that's everything.
Okay.
But please open an issue because that should be updated.
Cool. Yeah.
So, hey, Sid here. So continue on the same thing. So the type values themselves are not encoded and sent. So you're saying the type values are stored like encoded in scale and stored in metadata, but the actual values are given.
So I just want to explain that scale is just a scale is a serialization method that is based on encoders and decoders that encode data like this, right? How you want to later express how this data should be read, this is something that has been evolved quite a bit a lot of time because we realized that there are better ways of conveying this information, and it can be done separately. So for that, we have something that is quite specific to the runtimes of Polkadot, which is the metadata I think Victor is going to do the session. I don't know if it's no 2 from now, and then there we have the types, right? But you can also use scale in a way that so the meta is basically important for the developer experience and for developer tools and stuff. At the runtime, which is something that we'll be learning soon, it's completely irrelevant because the runtime is already being compiled with the type information, and it already knows what it needs to do with everything we need the code to. Does that make sense?
Yeah. And another question. So, can I put a different type into? So let's say I'm setting an encoding for like U32, but if I have it stored as a string format, then is it possible for me to put some value and make sense of it in a string format?
Sorry.
So like if I change the type, is the data still giving me out garbage or actual values when I change it?
If you change, sorry,
I think I understood. Yeah. So, the thing is that what happens if you try to decode a blob of data that it's expected to be a string, but you decode it as a number? Does it give you data? And yeah, the answer is yes. So
well, the answer is depends.
it,
It depends.
exactly. It
You,
might
you
give
can
a
get
value.
you can get runtime error, like basically. It depends. Like if you try to code a compound and don't know that it's not by compact value because not all permutations yield a value. So it depends. Like it's a little bit of an XY problem. Like I mean, like that's not like well, what would you like? It's like,
And last question. So, what happens when the like this is sequential the encoding, right? So what happens if the structure is like unordered, like hash map or something? So
if the what?
so if the structure that we are
Is there a way to like it's like it's those focuses there like they are killing me a little bit? Like can we turn them down a little bit? Sorry, you were asking. Sorry.
yeah. So if we want to decode an unordered list, like a hash map or something, then scale is sequentially encoding everything, right? So how does it handle like hash map? So
Right. So that is something that you handle at the application level. At the application level, right? Like when the application logic knows that oh now I need to store this because I need to decide how I'm encoding it and how am I going to put it, and it's up to me to make sense out of this data. But this comes at the app level. Oh, this is perfect. Yeah. Another question? Yes, because I want to show some examples.
Okay, well, it's basically I'm confused with the example with 0x05 because I was expecting like doing kind of shifting for the 2 bytes, and I didn't get why.
Yes. Okay. Let's. I like that. Okay. Let's So the compact for a compact value, you're saying like a compact value, y 0.05. Go ahead.
The invalid one, 0x05.
Okay, so we have this thing here that is let's do something, okay? Let's say we are only interested into a compact value, okay? Let's remove this compact value. And which one is the one that you're that
It is the 0x05.
0x05.
Like yeah, when in the
Right.
example 0.
So if we try to do 0.05, you see this red box is telling us not bueno. This is bueno. Why? Because 0x05 0x05 is this one, right? 0x05, sorry, 0 05. This is 1, 0. No.
It's 1010.
Okay. So remember, these two here are telling us the move, right? Remember?
Here's my question. The last two bytes should have
The last two bits.
sorry, the last two bits has the flag, which is something we are shifting, or we don't have shifting here. We're not doing shift. We are not shifting the bytes.
Like now, the way it works is first we look at this. Right? Like we know that there is data here. Right now we don't care. Right? Now we come here and it's like, oh, this is telling me that I'll have to take into account the next byte. Right? There's a problem. If you only have 05 with no zeros, there is no next byte. Now your question is like, what happens if there is another byte? Like if I do 0500, is that correct? What like, okay, let's go to the different cases, right? If you have 05, this is telling you need to take another byte, right? But there is not another byte. So when you try to take the other byte, you're going to get a panic or a runtime error or something because it's going to blow up. Does that make sense?
Still confused. Maybe I can discuss with you later.
Okay,
on.
so basically right now in memory we only have one byte. Yes, which is this one, this byte. Yes. Now this part of it is telling, hey, go get the other byte in order to compute this number.
Like my
The next
question is like the flag itself should be separated from the value, whatever. Like it just like give you like where you should look for the value in the is correct. So it should be like it's not the value of 0x05 is 5 in decimal. So it should be like separated. This is what I understood. I might be confused. It's my first time to learn about it. So
Don't worry, we're here to solve the questions. So let's go 1 second to this.
the last two bits shouldn't, like in my understanding, should be tied to the actual value itself. It's just like tell you the range. Like it should be from X to Y, and then you can find the value itself from reading the
No.
remaining bytes.
No, the way that compact works, so scratch everything that you have in your head right now. Like just scratch everything and let's start over, okay? The way compact works is we read the first byte. Inside that byte, before we start computing the number, inside that byte, before we start computing the number, we look at these two bits. Yeah? These two bits. And these two bits are going to tell us how many more bytes we're going to need, right? If these two bits is 0, they're telling us you don't need any other byte. You can now compute the number, right? If they say 01, it's like you need another byte, right? When you go, now you go grab the other byte and then you compute the number. And when computing the number, you don't check this. Like if it says 2, they are telling us you need 3 more bytes. And if it's 4, if it's 2, it's 3 more. And if it's 1, it's telling us, hey, these bits here are going to tell you how many more bytes you need plus 4. Yeah. So this is how compact works, right? So far so good, or yeah, so far so good. Okay, so remember, right? Like we read the first byte, and then we look at those 2 bits at the end. Before we compute anything, we ask ourselves, how many more bytes am I going to need, right? So what happens when we try to decode 05, right? What happens when we try to decode this? Is that we come here and we find 01. And we try to then get the next byte. This one here, just a problem. It doesn't exist. It's not there. So when we try to get it, it's not in memory. We're going to get a path, right? It's not. So that's why 0.5 is not a valid compact value. It's just this. So now the trickiest question, and there can be a little bit of philosophical debate here, but Charlo, just keep it, okay? Just the next question is, well, wouldn't 0.500 be a valid compact value? Because now I go, I read, I don't get a random exception because I go and get the next byte, right? And then I go and I compute it. There's just one problem, which is that, yes, you will compute it, but basically what's going to happen is that the value that you will get, let's look at this, like the value that you will get actually does fit into just one byte, right? So because we want to preserve property, you always want that when you have a codec, right? There can only be one way of encoding a number. There cannot be two different possible ways of encoding a number. Does that make sense? So if you encode, let's look at a simple example. Let's look at 0.1. Okay, 0.1 is very obvious. It's very obvious, right? It's very obvious. It's invalid. Why? Because this bit here is telling us you need another byte. Okay. And 0.100, it's like, okay, if I put that one, what value am I going to get? I'm going to get 0. But 0 fits in one byte, right? Therefore, it's invalid because if I encode it normally, it will always get encoded as 0, right? Like we'll encode it as 0.4 basically. Remember? Because it will be 0, 0, and 1 here. What?
He's saying that 0.4 is 1 and 0 encoded in compact value is
In compact?
Yeah, it's
Oh,
yeah.
sorry. Yeah. Sorry. Yes. Not 1. Yes, it's 0. But the point is that you could make the argument that it's like, okay, but I can actually record it. Yeah, like it won't break. It's incorrect. That's not that value when it's encoded will be encoded as something different, right? So that's why there are compact values that seem ambiguous or cannot have a valid compact representation. I hope that. Yeah. It's from
that no more. We are finished. I mean, in terms of questions.
let another one if they want. No one else wants to ask? That's perfect. Let's okay, just like 5 minutes. I want to show a few things. Okay. So let's play around a little bit in the complex, right? 0 is 0, as Victor was pointing out. 1 is 4. One thing that I wanted to show you. Okay. All right, so these are the Puppy Dev tools. I just want to show you some cool things that you can do and that are a lot easier to do once you're familiar with Scale. So for instance, this is a good example, right? Like a system remark, right? Like a system remark it's encoded as the remark itself. More? The remark itself is just binary data, right? So if we put text here, then we translate it as to binary for you. But let's see if we use binary data. So here we're using 1 byte, but then here you can see when we hover up here, in here, as we hover, you can see that the remark is 0401. Why 0401? Because it's using 1 byte, right? The first is a compact value, right? And it's telling us 1 byte. So if we go 02, 03, 04, 05, 06, 07, you see what is happening, right? Like 1C, let's go slowly. Remember, like 08 is compact encoded, means there are 2 elements here, and these are this one and this one, right? So if we put a lot of them, you will see that this value here is the compact encoded value that describes how many bytes we have here, right? So, okay. Now, it's like, oh, I want to do a system remark, but I forgot that I want to put that into a batch call. A batch call is just like, it's, remember, the variants that allowed us to have circular types? So a batch call is actually, we're going to copy this data, I'm going to put it in my clipboard, and now here I'm going to come, I'm going to do utility dot batch, right? And now I'm going to add an item, and I'm going to be like, ah, I already have the binary data of this item, and I paste it. And we have that same remark that we had before. So if I want to put it 1,000 times, in fact, oh, we didn't deploy the, oh yeah, we can copy it, right? So we can see the same binary data over and over. Or if we can change it, it can be hello world. And in fact, we could also get like, oh, I want to do a batch inside the batch just because I'm very fancy. So you can come here. You get all this binary data. Let me copy this binary data. And now I'm going to do a batch of utility. Sorry. Here I put what I had before, and boom, they get nested, right? So what I'm trying to explain here is that you can use the dev tools of PAPI to kind of make sense of the binary data and play with it. There's another tool that can also be quite useful if you want to, and if you want to check or encode or decode custom scale data, which is this scale tool that Victor created using some of our libraries. And here you can see some examples. Compact value, 100. Here we go, a variant. You can see that different values, different variants for. So hopefully this tool can help you visualize and understand each, like how the binary data gets produced. Does that make sense? So if you need to, oh my gosh, how does this get encoded in compact because you don't want to calculate it yourself, you can come here and see it. One last thing I wanted to explain, that you can try, oh, this one is in localhost, but you can try it in scale.papi.how. If you want to try it on your own and you want to play around with it, like this afternoon or wherever, to see how things get encoded, try scale.papi.how or use the PAPI console. And basically, this is going to help you debug in the future the binary data that is used for everything. Um, one very last thing that I know that some people were talking before is that one thing to keep in mind is when using compact is that when there are many bytes, the way that we compute it is the first 6 bits of the first byte, those 6 bits are the least significant bits. And then when we grab another byte, what we do is like we left shift it as many bits as we have used, and we do an OR. And we keep going and going and going. And that's going to give us the final value. This is how the values get computed. Does that make sense? And if there are no more questions, hopefully there aren't, I'm going to let Victor do the next session. Oh, let's do a 5-minute break, and then we have the next session.
Okay. Luego, uy, el, ¿dónde está el- Sí. Hola, hola. Bien. Vale.
Just quiet out. My life and love might still go on in your heart, in your mind. I still love. If I could, then I would. I go where you go, where I'm high or down low. I go where. If I could.
But anyway. Sí, sí. Són 30 minuts, anar més. És a les 3 el break. I ja està, sí. Sí, està. All right. Let's continue. So yeah, first, like quick introduction. I'm Victor. I'm also from the Puppy team. And yeah, he already presented who we are and a bit all of that. So now we will stop thinking about binary data and scale encoding and all of that, and we will go a bit into sort of more like blockchain stuff, right? So this lesson is about the runtime, and the first question is like, what will be the runtime? So what you will learn in this session is all of these questions, right? What is the runtime? Where is it located? How does it work? The trade-offs of having a dynamic state transition function. I'll explain what that means. And then also, what does it cater and the types of runtime APIs. To put everyone in context, because if I start directly like, what is runtime? Maybe people are still a bit thinking about scale. You have already, correct me if I'm wrong, but you have already done something about Polkadot and blockchain, how it works and everything, right? So what is the runtime and what is, or how does it fit into the architecture diagram? Because like, if you think about it, like what makes the blockchain is just a bunch of nodes talking between themselves. And people just send transactions, and these nodes just gossip the transactions between themselves. And there's like a consensus mechanism that that is the one that tells which transactions are the ones that are going to be included in a block and all of that. But I want to make a distinction here, right? So one thing is like the node itself, which is like Polkadot SDK, well, a part of it, which is that part over here, that it has transaction pool, it has a consensus mechanism, it has the database, so where it stores the state of the chain, but also like other components that is like to communicate with other nodes through P2P or JSON RPC for light clients. Sorry, not for light clients, for dApps essentially that want to communicate with that. And then there's another piece, which I call the runtime, that I'm putting outside the node, but you have to think that this is actually inside the same process, right? That is running, but I want to put it separate because this is the distinction I'm making here, right? So this is actually the business logic, is what controls the business logic of the blockchain. It's what says what transactions are, what is the structure of the storage, how is everything in there, right? So this is why we have this box here, which is the runtime, that has a state transition function. And then the way that these two parts communicate with each other is that the node calls runtime APIs from the runtime to do many stuff. But then the runtime can also call host functions in order to do stuff that we will now explain a bit better. So I want to say, by the way, if there's any question, just raise your hand and I'll give you your turn. So runtime, what is it? So it says here, it's the logic of the state transition function that defines the business logic of the chain. Now, what is the state transition function? Is anyone knows what the state transition function is? There's, well, that one, or Mike. Mike? Nope. Yeah.
Hold on. I guess it's the logic that takes in, like when a block comes in, it applies it to the chain, or like it applies it to the state, the current state we have.
Yes. How does it work? Like we will talk a bit more on the next slides, but essentially, well, as you said, yeah, that's a good point. So it essentially is like the function that just explains the business logic. So the idea is you have some state, you have a piece of state, and then you have a function that says, okay, given this state and given a transaction, how does this state change? And then that gives you a new state, right? So that state transition function is just something that, takes a state and keeps evolving it. Yeah. So currently it's in WASM, because this is how Polkadot was developed. Like again, like there are so many trade-offs. It's now there's an ongoing work to make it Polka VM instead for Jan. But and this is actually one of the main points, is that it is stored as part of the state of the chain. So the runtime. So why did I make this distinction on the previous one? It's because this node over here, this is something that gets compiled into into the native architecture of whatever server you're running, and it's just a process that runs it, right? Whereas this one is actually compiled into WASM, and it's run as sort of like in a virtual machine of that node, if that makes sense, right? And this code is actually part of the state of the chain. Yeah. And this has some very serious implications on that. So yeah, it's part of the state, but if you think about it, like this is also the function that says how the state has to change. Yeah. So the idea is that we have like a bunch of state. So we have balances, we have NFTs, we have identity, but we also have the code of that chain. And this code is actually this state transition function. Yeah. So this state transition function takes the whole state, takes an extrinsic or a transaction. It's the same concept. And then it gives you a new state. Yeah? And then you take this state and a new extrinsic, and it gives you a new state. So most of the time, like if you look at what's happening in a blockchain, you will see that what changes most of the time is the balances, because, well, at least every time that you send the transaction, you have to pay a fee. So balances almost always gets updated. And then maybe you also have a couple of changes in NFTs, and usually the code doesn't change. You don't expect the code to be changing all of the time. But this allows that at some specific point, maybe one extrinsic will cause this code to change into another one. Yeah, and then the next state transition function is going to execute this code over here that has been changed instead of the previous one. Yeah. So why do we put this as part of the state? Anyone can guess? There was Mike there. It's coming.
To avoid the forks, like forkless upgrades.
Exactly. That's exactly the word I was looking for. Forkless upgrades. Yeah. So if you have like a blockchain that the code is compiled, and then every node has to upgrade and all of that, then every time that you want to make some change on your business logic of your chain, it means that you have to talk with every single node operator around the world and tell them, hey, please, we have a new version of this. You have to coordinate everyone so that they all upgrade. And if it's a hard fork, then it's probably all of them at the same time, which is not easy to do. So yeah, that's quite costly, right? So why forkless upgrades? I put this like rainbow because yes, right? Like this allows forkless upgrades, but there's a bit of an asterisk here. It's in an ideal world, it will be forkless upgrades. However, there are some cases where you need to do something, right? Like it's not very, you can call it like almost forkless upgrades, or most of the time forkless upgrades. Yeah. So how does that work? I more or less already said this, but the idea is that when a node that's running the blockchain needs to execute a block, so like all of the transactions and all of that, so it will take the code of whatever was back then, and it will what's called instantiate it. So it will compile that WASM into something that it can actually run, and then it will just start applying extrinsics, right? But it needs to watch when the code of the chain changes, because when that happens, then what it needs to do is reinstantiate that new WASM, right? Because now the next transactions are going to be with the new code. So there's something that's, and this is part of like this asterisk of like when these forkless upgrades doesn't always apply. But essentially we have what's called host functions, right? So the host functions are that box that is inside the node itself. So it's essentially what's compiled into an executable. And the WASM is communicating with these host functions, right? And what does it need from that? So for instance, the code doesn't have the storage. It doesn't have the state of the chain. So every time that the runtime needs to access some part of the state, then it needs to go to the node and tell it like, hey, please, can you give me the storage value for this key? right? I need to know the balances of this user because I need to see if it has enough balance to make a transaction, right? So there's a host function that is like get storage. So it's like get storage with this key, and then the node will go to the database, fetch the thing, and then come back, right? So this brings up this question, right? It's like, can it happen then that you have a new WASM that needs new capabilities? And the answer is obviously yes, right? And then what do you do in this case? What are the implications of that?
It also needs to be backward compatible. If we want to run the host call function, for example, I don't know, some host call function change the number, which we want to call, and some nodes are still trying to run this function. And for example, if it wasn't existing in the new, or it was replaced, then it will be unexpected, right? Unexpected behavior. So
yeah.
it also needs to be backward compatible.
Yeah, well, one way that you can solve this is with backwards compatibility. But another way you can solve it, you need to do something else which is not backwards compatible, because sometimes like you are constrained by that, right? It's like, I want to do a change, but it's not going to be backwards compatible. Like, I don't know, like there was a point in Polkadot, like very, very early on, where the way that the weight is calculated changed. So instead of only being based on the time that it takes to execute a function, it also included the proof size. I don't know if you're familiar with this concept, but Polkadot works a lot with trustless, sorry. So essentially trustless, it means that it doesn't, like every node, it will not trust any other node in the chain. It will think that every node is sort of like malicious. So every time that a node asks another one for some piece of state or whatever, that node has to bring in a proof. So this proof is usually quite large, or it can get very, very large. So this is why, as part of the transaction, there was a change that it was like, okay, we need to include the size of the proof into the weight, because then the fees need to be calculated. And now that was a new, it was a new host function that there wasn't needs, right? But then how do we do this? This is not like you cannot do a backwards compatible change with that. You cannot say like, okay, I'm just gonna release a WASM that, you know, if the host function has it, if there's a host function for the new weight management, then I'm gonna use it. Otherwise, I will not, because then you have nodes that work in a way and nodes that don't work in another.
So let's say you require new different version for new WASM. We don't have new version, so we shouldn't upgrade, right? That node. And other nodes that have new version should upgrade. We can require, and maybe then validators could manually hard fork new node if we want to as a validator. And like the WASM version for newer nodes will upgrade, and for the older nodes wouldn't, just will be same, right?
Yeah.
So that's the trade-off.
Exactly. Yeah. Okay. So that's the thing. Like essentially, like we have to try and minimize these type of changes, like because this is a hard change essentially. There's no easy solution in this, right? Like the way that the runtime works is that, you know, it allows you to make any kind of change that you want to do the business logic. So like if you want to update a palette, you want, I don't know, to add a new function into balances, so you can do like balances dot, I don't know, anything, then, you know, it will be forkless, right? You just like open a PR in Polkadot SDK, that's where the balances palette is. And that gets merged in, and then it gets into a Polkadot release, and that release is scheduled, and, you know, it has been upgraded. And this happens like quite often, actually. And this is all fine. But we still need to think that there will be cases where, for instance, like this weight calculation thing that you need now to coordinate everyone. So we have essentially like this runtime covers most of the upgrades, but it doesn't mean that it just like completely replaces them, so that now everything is forkless. Like that's not possible, right? At some point, like it's like a tiny this change that it has this problem.
Victor, yeah, there's a question here.
Oh yeah.
So two things. First, when we say almost forkless upgrades, do we mean reorgs, which happen pretty frequently? And secondly, when we refer to something as a host function, are we referring to the runtime API or the executor?
Yeah, this is also a good question. So what I meant is like for the host functions specifically, right? It's like when you need to create a new WASM that needs a host function that is new or well, if it has changed, then it's even more problematic, right? Usually you would just like add a new function, but then you have this problem that you have like to communicate with everyone that they need to have that new function there. The runtime can add more runtime APIs. That's not a problem. And also, like that's a very good question because this raises another point. It's like another advantage of having a runtime that is part of the code and everything else is that if you think about it, the runtime gets updated instantaneously, right? It's like the consensus of the blockchain. Essentially, like the runtime is using the consensus of the blockchain so that everyone is like, okay, now it's the new runtime, and now everyone has updated automatically into that one. You will not have a node that is running an older runtime than another, right? Because everyone knows, okay, this is the finalized block. Hope you know what finalized block means. Yeah. So this is the finalized block. So this is the current runtime that everyone is running to. Yeah. So in the case that imagine is like that I need to make a change in the blockchain, the protocol, where I'm adding a new runtime API that I'm thinking that nodes will need later. So you're gonna do this of like, okay, first I'm gonna release an upgrade on the runtime, and now the runtime upgrades everywhere, so everyone has it. And now I can create a new release for the node that everyone can just like update at their own time, because maybe it's like an optional process that they can do for optimizing who knows what, right? But then you can do that release, and then every node operator can just like upgrade. And because the runtime has been upgraded everywhere, you're guaranteed that they will have no problems, right?
So I'm pretty sure it's not it, but like when you create a block, the runtime is not in that block. The runtime is or the not the runtime, the state transition function. It's not in the block. It's actually just something somewhere on the chain itself, and you say where it is. And if you do an upgrade, like say if you were n-1 and you're going to do an upgrade, there's a function that says, well, change that pointer for the state transition function from here to here, and then the next block knows to use that as where to do the state transition function. I'm trying to understand where does the STF actually live in terms of like when you're producing blocks.
So it's part of the state of the chain, right? The block only has transactions. Am I answering your question?
Yeah, so like you're saying it's forkless because the STF is always known in every block produced, but the only way to do that is if you know a specific location is always going to be it. So like what stops someone from overriding it and saying, well, I'm using this one instead of this one?
Yeah. Yeah, well, it has like a known key. So the state of the chain is essentially like a key value store.
Right.
And it's by convention that it's colon code. So this is by convention like the key of the code of that. And then this is essentially just inside the storage of the node. So it's using a database that it is storing on disk, then it will be there.
But if you're doing delegated proof of, like you're doing proof of stake, so there's a validator who's writing the block and he's like everyone is validating, but he can't change the code value because the validators won't validate it. Is that correct? Is that
I
how it
don't fully
works?
understand the question. I don't know. Mhm.
But there are two things, right? Like so.
No. The thing is that we said the code is in the storage, right? The storage, as it is constructed, it's Merkleized. So there is the root hash of the whole storage inside every block. So only one code can verify, so can construct the right proof, so that the Merkle root is the one that is on the block. That makes sense? Yeah, this comes later. So
There's just another thing, which is like the node, as Victor explained before, right? Like it instantiates the WASM version. Like imagine that you have a like client. You will learn the different kinds of clients later, right? Like, but like you don't need to have a node that kind of processes everything. You can have one that basically downloads the latest code, right? It knows that this is the tip of the chain. It knows this node, this block is finalized because there are these proofs, and it just gets the code, right? Instantiates the code, knows that this code is valid at this block, and now, how does it know that it has updated? There is an actually more efficient way than constantly checking the state, which what Victor said is true, but because every time that it changes, there is inside the header of the block, there is a flag. Let's just say there is a flag inside the header. You will learn a little bit more later if you want in detail where the logs are, that lets you know that there has been a runtime upgrade. So even a live client, because otherwise the live client will have to constantly be verifying. It's like, oh, because I've seen this flag like that, now I need to download the code and reinstantiate it. And from this block onwards, this is the new state transition function. Does that make sense? I think this is what you're looking for. Right? You are not only, because otherwise, how can a live client constantly be checking? It doesn't seem that efficient when it doesn't happen that often. That's why there is this flag there that kind of indicate that indicates that there has been a runtime upgrade. Sorry, just like small clarification.
Okay. Thank you. Ra here. My question is, what's the relationship between node host functions and the runtime API? Because if there's like new host functions, I mean, are they mapped one-to-one to runtime API? Or how does the relationship works, basically?
No. So there's like no relationship between host functions and runtime APIs. So host functions is just like, you can think it of part of the context that the runtime is running, so that the runtime can always call them at any point. It's like, oh, I need to call to get the storage of that. Then it calls that. Oh, I need to now I don't have another one. Yeah, I need to calculate the hash of something, because you don't want it to run in WASM, because then it's a bit slower. There's actually a host function to run the hash really quickly. So that's another host function, right? But then the runtime APIs is just like the face for the node. So the node, it has all the consensus mechanism, and it has the transaction pool and all of that. But imagine like when it wants to execute a block, then it's like, well, I have this bunch of transactions, but I don't know what to do with them. So now it calls a runtime API, which is called execute block, that it just hands all of the transactions to the runtime, and now the runtime will run these transactions and create a block, right? And it will come back with a result. So it's just like you can think of like the runtime API is just like the face for the node, and the host functions is the face for the runtime.
Yeah. I guess in the case of a hard fork, does it mean that the node prevented itself from receiving an update to the runtime API, to the runtime?
Like if there's a node that hasn't upgraded in time, then yeah, it will have problems executing blocks, right? It will receive blocks from another nodes that it will say like, wow, this block is invalid, or I can execute it, or I panic, or whatever.
Yeah, because I was thinking like if a node had received the upgrade to the runtime, but the node itself hadn't updated, then I guess that's possible, right? Because the runtime just gets updates from.
Yeah.
So in that case, then there wouldn't really be a hard fork because it wouldn't be able to produce blocks unless it prevented itself from updating the runtime.
Well, that specific node will not be able to execute new blocks or create new ones, right? Because yeah, it has a runtime that it's using something that is not there, so it will probably panic and yeah.
And is the state of the runtime or the version of the runtime included as part of the block that a node creates?
I think. Yeah.
More or less, not directly, but as we said, the whole code is included in the storage, and the storage is Merkleized, and you get a root hash, which includes the code. And inside the code, actually, there is a constant that tells you the version. So indirectly, it is inside every block, but not as a like.
No, now that I think of it, it actually is because like when you perform a set code to make a runtime upgrade, there's actually check that the version has to be bumped. If the version doesn't increase, then so it's part of the code essentially.
Yeah, exactly. Is a constant.
Yeah.
Yeah, and the very last one, and then after the break, we answer the rest.
So let's say in block N we get a code upgrade. The validator nodes have to vote in it like for consensus, right? So when does it actually apply? Like when does the code apply? Is it N+1?
Yeah, well, it applies to the next block. Yeah.
Okay. So not the one where it's
no.
Okay. Yeah.
Otherwise, it would be a chicken and egg. Yeah, we have to take a break because it's one of those hard breaks. Oh. Yeah. What? No, well, yeah. Let's take the break that we have planned. I think it's like a 30-minute one, and no, it's fine. It's fine. Yeah, and then we continue later.
Cool. Thank you, Victor. So quickly before we go for a break, 2 notes from me, then 1 quick one from Nikos. If you arrived to the PBA check-in this morning, just got your t-shirt and your lanyard, and you didn't get any other swag, please come to me and Maria here. We have some fans and some stickers to give to you as well, if you would like them. A second reminder, I know a lot of you are jet-lagged, you're tired, it's been a long journey, it's been a long day. If you need a moment to close your eyes or just step outside or whatever it is, please don't do that in the classroom. Please don't sleep in the classroom. Please, like we said, be present in the classroom. We've seen some of you doodling, some of you on your laptops and things like that, doing things which are not relevant to the classroom. That is part of our expectations of you being physically and mentally present, watching, listening, and learning along to everyone, to the instructors on stage. So we are looking, we are watching, and we will talk to you if that is an issue. But just, again, setting that expectation that you need to be present in the classroom. I think that was it. Then Nikos quickly has something to say too.
Hey, as we said in the morning, the truth lies in the Google Calendar. So I added for tomorrow afternoon at 5 o'clock, 1 hour registration if you want and brainstorming around use cases. So everyone who is interested in participating in the real life use cases at 5 o'clock in the afternoon after the lectures, in the abstract room, which is past the toilets around the corner. We will be there with the mentors, or at least the ones who are on site at the moment, and we will start discussing, we'll start building the whole thing. Come, we'll have a channel in Discord afterwards, and even if you don't come tomorrow because you're tired or anything, you can join later, but tomorrow the whole thing starts and we'll go with the flow. Have a nice break. Thank you. Thank you, Victor. Thank you.
Back at 3:30, guys. 3:30, we start again. Thank you.
Sure.
No, I can't deal with it.
Tell me you want it as much as I do. Try to catch. I wanna hear you say.
I wanna hear you say that I've got your heart.
Probando. 3, 4. 1, 2, 3. Check, check, check. One, two, three, check.
Yeah.
Stay in the middle of the night. Heading towards the light sky. Just hang on to me for the rest of your life. When the stars across the sky. What's the goal? Find out if
All right, Sophie, do you hear me? I'm checking, checking. 1, 2, 3. Hola, Sophie.
Hello.
Sí, hola, sí.
Yes.
Hola, sí.
Can you hear me?
You hear me, Sophie?
Yes.
One,
Can you
two.
hear me?
1, 2, 3. 1, 2, 3. Check, check. 1, 2, 2, 2. You hear me on the speakers?
Hello, hello.
Oh, 1, 2, 2, 2. 1, 2.
Yes. I am here, but can you hear me?
I'm receiving audio from here. Could you please put it? Mm, mm, mm.
Yeah. So what's the result?
Apparently it's working fine. I'm making a final check. I need to put, I'm receiving audio from the external Meet. I need to put it on the PA.
Okay. Oh, so we haven't received any sound from there yet.
Hello,
Sophie?
hello.
I hear you,
Yes.
Sophie. Here you are.
Ah. Hi, everyone.
The people look with a strange
I
face.
don't know. Yeah, this is Jofi. Hope everyone's having fun.
Sophie, we miss you. Do you hear me?
Yes, I can.
I can hear.
Yeah.
Okay, perfect. We are good.
Yep.
Thank you for the test.
No worries.
Bye bye.
we go. You and I will find out where you're going. Tonight has just begun.
Save me, save me, save. Save me. It's not gonna last, all the things can like so why I'm losing time. I don't get up or bring me what I need, so why I was losing time. It's like I've seen the light, but yeah. Save me. Even if the lights go out, even in the sunlight, even if the sun comes out, ooh, we keep on dancing, keep on. Even if the lights go out, even if the road is long, even if the heart is broken, oh, we keep on dancing, keep on dancing. I'm not till September. This music is my best friend. Once you tell her to order flowers, I want her to remember. Music is my best friend. It's Rosie. I'm not till September. This music is my best friend. Once you tell her to order, I want her to remember. Music is my best friend. People dancing, even if the lights go out, even in the sunlight, even if the sun comes out. Ooh, we keep on dancing, keep on, even if the lights go out, even if the road is long, even if the heart is broken. Oh, keep on dancing. It's Rosie. I'm not till September. This music is my best friend. Once you tell her to order, I want it to be left. Music is my best friend. It's Rosie. I'm not till September. This music is my best friend. Once you tell her to order, I want it to be left. Music is my best friend. It's Rosie. I'm not till music is my best friend. Won't you tell her to music is my best friend.
Sunny, yesterday my life was filled with rain. Sunny, you smiled at me and really eased my pain. Now the dark days are gone, now the bright days are here. My sunny one, joy is so sincere. Sunny one, so true. I love you. Ooh, sunny, I wanna thank you for the sunshine you gave. Sunny, I wanna thank you for the love you brought my way. You gave to me your all in all. Now I feel 10 feet tall. Sunny one, so true. I love you. Oh, Sonny, I wanna thank you for the facts from A to Z. Sonny, I wanna thank you for the truth you let me see. My life was torn like a wind-blowing sand, and a rock was born when you stepped in. Sonny, one so true, I love you. Oh, Sonny, I wanna thank you for the smile upon your face. Sonny, I wanna thank you for the sweet and warm embrace. You're my spark of nature's fire. You got my soul and my desire. Sonny, one so true, I love you. Oh, I love you. I love you. I love you. Love you. Oh, I love you. Oh, yeah. Love you. Oh, yeah. Oh, love you. Oh, I love you. How do I want to talk? Right at the edge with your heart in a chokehold, heart in a choke. Maybe I'm a lost cause I got hope. I know what I know to what I'm told. So you should know, you should know, you should know. Oh, don't know how to give you my, don't know how to give you my love back. Cause I'm too good at fucking it up. Maybe I can change, baby. Now you should know. Everything is changed, but out of control. Oh, I don't know how to give you my love. And if I told you now, honey, would you let go?
go. Cause I've been so far down, high as low. See too many faces, too many places. Been through many phases, end up alone. If I leave you now, honey, would you let go? Let go. Oh, get him. So just forget it up. Forget it up. Maybe change. No, you should. It's strange. No, you can give you more love. Give you give you love. Give you more love. Give you more love.
Know you thought I'd never be really much of anything. While you were telling me I turned against the wind. Oh, when my eyes started to burn, you turned your back on me. Well, you see, I slipped away. Now turn to me. 'Cause I've done 100 things you've only dreamed. So don't come crying to me. Don't come trying again. I have a feel. Don't call us friends. 'Cause I don't remember finding how it used to be. No, I don't remember finding how it used to be. Don't call us friends. And you waited all alone for your luck to come along. You were real. Well, you see, it slipped away. Now turn to me. 'Cause I've done 100 things you've only dreamed. So don't come crying to me. Don't come trying again. But I have a feel. Don't call us friends. 'Cause I don't remember friends. How it used to be. Oh, I don't remember people. How it used to be. So I'm glad. Don't come crying to me. Don't come trying again. But I have a feel. Don't call us friends. 'Cause 'cause I don't remember anymore how we used to be. No, I don't remember anymore how I used to feel. Don't go.
Okay. Yeah. Yeah. Okay. We will continue. Please sit down and Joseph. Okay. Maybe that there were more questions. So first we will go through them. I had also someone come to me with a nice question, which I think it's nice to share, which is like these like forkless upgrades and all of that. Like, is it really forkless? Because if we have a network partition where we have like 50% of the nodes on one side of the world and 50% in another, then one node will have like a new version of the WASM, whereas the other one will not have a version of the WASM. So yeah, that's true. Like in this case, we have a fork, right? Like we have one fork that is like running a newer version, and the other one is just like running on the old one, because the old one has never seen that code, right? But the answer is that this is just part of the consensus, right? Like in this case, we are talking about a runtime upgrade, but it could be like a balance transfer that is also in one fork and not in the other. So what will happen is that the finalized block will be the most common one, and then you will have like two massive forks spanning on each side of the country, but none of them will finalize, right? And then when the network partition resolves and now the nodes start talking to each other, they will see, oh, there's actually a fork. So now we have to use the consensus mechanism to say like, okay, which one of these two forks is the correct one? And now one will get finalized and the other one will get thrown away. So I don't know if there were more questions of everything we have said.
So my question is, for a state change to happen, does it only have to be a transaction? For example, you say that the runtime is part of the state, and if the runtime is upgraded, is that also a valid state transition?
So which one? Sorry?
I'm asking if moving from one state to another is only possible through a transaction or an extrinsic. Since you said that the runtime is part of the state, if an upgrade happens to the runtime, is that also a valid change of state?
Yeah. So like when you have like I'm not really sure if I understood the question correctly, but yeah, like when you have a runtime upgrade, it has to happen as part of an extrinsic, right? Like the extrinsic has to make this change, and once that change has happened, on the next block, it's where it's going to use that code that has been updated now. Yes. Yeah.
It's Ben. I was presuming there are some core host functions. I was presuming, if I'm looking at the parallel with maybe Solidity and EIPs and ERCs, and where functions are kind of they conform under this framework. But I was just curious about, is there a method of standardization for new functions, new host functions? Is there a standardized method, or if I wanted to build a new host function for a new project, a new app, new application that is not one of the core functions, how does it work out?
There's really not like just like telling every node operator, hey, you have to upgrade. It's really important, and there's nothing really much to, like we don't have like on chain. There's nothing that we can do to tell the nodes, hey, you need to update that.
I mean, realistically speaking, at least in the case of Polkadot, like there is the fellowship, right? So there is a process of defining RFCs. So when something like this happens, where there's a need for a major update, like, I don't know, beefy, or for instance, changing probably in the future instead of grandpa, we'll use an even better finality gadget. These kind of changes require a new host function. So when these things happen, there are off-chain discussions, obviously, inside the fellowship. There is an RC process, and if it's approved and everyone is cool with that, then what Victor said, right? Like, you need to make sure that at least a significant part of the validators have upgraded their nodes before you apply the new runtime that will require those host functions. But like, this is as Victor says, it's an off-chain discussion. And in the case of the relay chain, they decide to do it through this RC process, through the fellowship. But a parachain may have a different way of handling that. Maybe a parachain wants to be more centralized or more decentralized. It's up to them how to decide to make these changes, basically. I don't know if this answers, but yeah.
Hi, Luca here. So let's say we upgrade all nodes with runtime that's malicious, that doesn't work, and we cannot do new transaction to upgrade it later. What do we do? Do we just roll back? And how do we say to everyone, roll back this to this block? And yeah.
It's another hard fork, right? Like, you have to essentially make an upgrade to the node to say, like, okay, that block with this hash is not valid. You just hard code it. It's like, that block is not valid. And now, the nodes that have upgraded will continue the chain, and the others will be just stuck there because that code panics. It's a really good point. Like, for the ones that are in protocol track, you will see that it's very important for your functions to not panic, because that's a bad thing. So I'm pretty sure that Sean will repeat it so many times that when you add two numbers, you cannot just use the add operator because that can overflow, and if it overflows, then it panics, and things like that. But yeah. Any other? No. Okay. So trade-offs. Well, we have already discussed this, but there's another one that we haven't talked about. So, well, trade-offs, yeah, the good, the focus upgrades, blah, blah, and not so good. So first off, like, state migrations, right? We said, like, oh, it's so easy. You just like upload the new code, and the code is there, and now you have the native state transition function. But if you think about the state transition function, that is assuming a particular storage, like the state is stored in a specific way. I don't know, like the balances, for instance, is in a map of the account ID to their balance, right? So if I make a storage upgrade where I say, well, now the balances, because I'm going to support multiple assets, then I want to be a storage map of the account ID with another key, which is another storage map of the asset ID, and then I have the value. But now I have to think of how this state migration will happen, right? So this would be a more or less simple state. No, this will be actually a pretty hard state migration. But you can have like state migrations that are quite simple. That is just like, oh, you just copy these values from here and there, and that's done. But you can have like state migrations that are way more complex, right? And how do you do them? That's really, really tricky. So, for instance, now there was a migration on how staking worked in Polkadot. And the way that this is usually handled is that first you make an upgrade that, so an upgrade that essentially will be compatible with the upcoming change. Then you make another transaction that essentially performs the state migration, and then you activate the new runtime function or the new thing. So you need to do sort of two runtime upgrades to perform that state migration. So essentially it becomes a bit more complex. Now we have another thing, which is that transactions become invalid. Why is that? I mean, this is a fact. Transactions become invalid, but why do transactions become invalid? Why did they do that?
because we changed the business logic. Now transactions are processed differently, and then transactions may become invalid because of the new processing. Yeah.
Yeah, exactly, right? Like imagine that you as a consumer, you submit a transaction that you know that does something, right? It's like, oh, I'm going to submit a transaction to transfer some balance from here to here. But now there's a runtime upgrade that happens that says like, well, actually the value is going to be multiplied by 2. So you would be a bit mad, right, that they did this runtime upgrade, or at least that they have done this runtime upgrade. You have to know that your transaction is going to do the thing that you want to do, right? So there's this mechanism where with transaction extensions and all of that, that essentially tells like, okay, this specific transaction is for this specific code hash or this specific version of that. Yeah.
It's Nemanja. Does this transaction get encoded in the block and shown as reverted, or doesn't get encoded in the block at all?
So the code upgrade transaction gets included, and then all of the next transactions get invalid, so they will not be included in the next one.
So they don't even go to the block.
Yeah.
It's the transactions that are in the sorry. It's the transactions that are in the transaction pool that become invalid, right? Like the ones that have not yet been included in any block. At that point, whatever is in the pool gets trashed because it becomes invalid.
Okay. Yeah.
Just a question. Are these inevitable and just fundamental problems or trade-offs? Like, can us developers ever solve these? Or does that just come with time? Or is that just permanent?
I mean, at this point, they are inevitable, right? Like these are the trade-offs. If someone has an idea of like how to fix this so that then contributions are welcome, right? It's always this thing that there's always trade-offs when you design something. And probably if you try to fix one of these things, then you will have another trade-off that you are making it a bit worse for another use case, right? So essentially, like these are the current trade-offs that they have decided. And but yeah, at this point.
Hi. Hello. Here. Hi, Krishna here. So so I had a discussion with Carlo off stage regarding like who initiates updating the code. So the state transaction function. So who all can initiate? So would it be like right time to touch that, or maybe like you have it covered in your slide? Who all can like update or make changes to the code?
Yeah, that's a good question. Like, because I'm saying like this happens in a transaction, right? So what happens if I submit a transaction that has a set code with this code over here? Can I do a malicious transaction in that case? The answer is no, right? Because we have a permission system, so that transaction will not be valid because I'm not root of this. Like my account is not a root account of that blockchain, and so the transaction will fail. So how does this happen? Now it depends on the chain. Yeah. So on Polkadot, we don't have anyone that's a root account. We don't have like, oh, I don't know, Gavin Wood has a public key that he can do whatever he wants. No, that would be really bad. Not because of Gavin Wood, right? Just for the record. But what Polkadot has is a governance system where the governance has root access. So there's a track on governance, which is root. And in there, you can create a referendum. And that referendum will get called as a root user, a root account, sorry. So, you submit a referendum, you pay a very big deposit to put that referendum, so you cannot spam it as well. And then people will vote whether that runtime upgrade is going through or not. Now, it usually doesn't happen like that because we have a fellowship, and that now is the responsible of doing that. So it goes through another track, which is called whitelisted caller, I think, which essentially lets the fellowship make releases and keep things a bit more fluent, essentially. But yeah.
Yeah, Adrian here. I have two questions. One is, say I did
pay for gas to run a transaction, and then the transaction it fails because of a runtime upgrade, do I get refunded on the gas?
It depends. So if the transaction is invalid, then you will get a refund. Like essentially, the transaction will not execute. So it's not part of a block, so you will not get charged.
Yeah, it's as if it never happened.
Yeah, but if the transaction gets executed, and now the process of that is like, no, this cannot happen, then you will have paid for the gas, and there's no around it. Yeah.
Okay, my second question is there any solution to this where basically it's just a reattempt, an automatic reattempt at a transaction if the first one fails because of this kind of scenario? Or
if a transaction fails, it has failed and it will fail forever. But I think that there's a better point in here, which is, when this transaction of set code, it's massive, right? It's like really, really, really big. So usually usually like the fee that you have to pay for this is like really expensive. So it's like, who pays for that, right? So in here the answer is like no one really. So essentially what whitelister caller does, that transaction is just like, okay, we are going to allow a runtime that has this specific hash, but it's not the actual runtime itself. So now that transaction is really small, everyone votes on that, or whatever, it gets executed, and no one pays fees. And then the way that the code is executed is with an unsigned transaction. So now you do an unsigned transaction of, it's called apply authorized upgrade. Well, and in that you pass in the whole thing. So it's a very big chunk, but nobody pays for that.
Is there was here?
Hello, Kyle here. Can you hear me? All right.
Yes.
Basically, I wanted to ask, when you have a dApp, obviously, and you need to get the new state, does it query for the node to get to the runtime of the newest state?
So, come again?
Basically, when I need to get the state in my newest dApp, I'm guessing it queries the node using JSON RPC, and then the node then goes and queries the runtime for the newest state. How does it work?
Okay, yeah. No, so it doesn't go through the runtime in this case. So like the node essentially will just like directly access the database and just like pull that value and just throw it to you, back at you. Like the runtime is only for making the transition. Yeah. Well, there's an asterisk to that. We'll come to that later. Yeah.
Yeah, you mentioned referendums, right, for governance. If we go through that route and you do this transaction which introduces a core, like a runtime upgrade, would there be like some sort of timeout for the votes? Like I'm assuming like if you don't get enough votes, then is that how it works?
Yeah.
All right.
But again, like this is just part of the referendum process. But if that referendum after 28 days, I think it doesn't have enough votes, then it just gets rejected. That's all. Yeah.
So what happens when the code that you're injecting itself is malicious, or like it has some error in it? How do you revert back from that?
Well, the thing is that you have to verify, right? The code that is there is not like so. For instance, like in case of Polkadot, so we have all of the palettes are in Polkadot SDK. So everyone that makes like a contribution there, which is welcome, it gets reviewed, right? So now people will check that your code is not doing anything malicious in there, and then it gets merged into that, and then at some point they create like stable releases essentially. So it's like, okay, from this point onward, like we're sort of like code freezing, and then we're going to try it in Kusama, and then then I don't know, Paseo, and then Westend, and then Polkadot, right? So it gets through multiple stages to make sure that it's not malicious, but the idea also like with specific this is like when a runtime is made, when a runtime upgrade is getting published, again on what's on chain is like the hash of the runtime. But this also means that anyone, because like, oh, what does this hash mean? Well, you can just go to the Polkadot SDK repo, build your own runtime, calculate the hash, and you will see that it's the same. And it's like, oh yeah, it's not malicious. It's not. They are not uploading anything that's not going to be the official one.
I was just wondering, where exactly is the runtime downloaded from?
Downloaded?
Like, there must be like somewhere, like, if the runtime is upgraded, where does it come from? Is it from like another node? Is it from like some endpoint?
No, well, as part of the blockchain, it's just on the state, so it's in the database, right? And this is like when it gets so like every full node has their copy of the of the runtime.
Yeah, but
then for a runtime upgrade, where does it get from? Well, from the CI of GitHub Polkadot SDK or the Polkadot Fellows.
I think someone else was like asking me to start telling me about this, but I guess that seems centralized.
As much centralized as Git, right? Like again, like you can just like fork that repository in your own computer and then just build it. Like there's a command to just build the runtime, and then you will have the WASM that you can do whatever you want with that. Yeah, that makes sense. So it is centralized because yeah, it's in a place, but I mean you can just fork it. So
okay,
right.
I guess that makes sense. Yeah.
Yeah, like at some point you need to have some sort of like centralized place of just so that everyone knows where the code is, right, and where to make contributions to. If it was like completely decentralized, then how do you coordinate all of these people would be really, really hard. Yeah. There are more questions here and there and there.
Go ahead.
Hello. Yeah. Hello, I'm Kelvin. I want to ask how to, let's say, some services that build on parachain, let's say we say dApps, and because there are some runtime upgrades that faultless from the parachain, and some user that already use their specific dApps, suppose that already, let's say, invest or lock their fund in that kind of services. And because the faultless upgrade is, is governance by the parachain, and that impacts the specific dApps user become, is a negative impact to them. Does it mean that how we prevent that kind of faultless upgrade that can happen in the parachain?
Yeah, well, it's a parachain or also the relay chain, right? Like this is like more or less the third point, which is that make it more complicated because now you have to deal with multiple runtimes. You don't just deal with someone, but you deal with the potential thing that it can break, right? Like it can get upgraded at any point, and now how do you deal with that? How does your dApp react to this specific change, right? If it's a small change, probably users won't notice. But if it's like something that's quite substantial, it can even like crash your application. So yeah, it is relevant.
Like, if the runtime upgrades in like the mid pool transaction, so like how does Polkadot ensure that like all the nodes rejects or like accepts the pending transactions?
So what do they upgrade?
Like if there's a runtime upgrade in a mid transaction pool, so like how does the Polkadot ensure that like all the nodes will reject or accept the pending transactions?
I don't get the question. Sorry. So it's
I think I get it.
yeah.
In the end, the runtime has rules on whether a transaction is or is not valid. So you can verify. You can ask the runtime, is this transaction valid?
The transactions are in the mempool, and like if it happens, the upgrade happens in like the mid transaction pool. Like what if there is a pending transaction?
So if there is a pending transaction in the transaction pool, when you verify, hey, all of these transactions that are in the transaction pool, is this one valid with the new block, with the new runtime? If it's not, I remove it from the pool. Does it make sense? Yes. You.
Jeff here. I want to follow up question about when runtime execute finalized, then how to look upgrade with the new version of runtime. Is the runtime included in the extrinsic so the old version node can get the update?
No, it's not based on version. It's just like on the next block, it's the actual. So I'm not. Maybe it's like when I said this thing of the hash, right? That I said like that what gets submitted is just like the hash of the runtime that will get upgraded. Maybe that's what you're mentioning.
My
Or-
question may be just there are no upgraded new version runtime, and the old node, how it upgrade get the new version of runtime. That's my question.
Well, as part of the consensus, you are guaranteed that everyone will have that block, right?
Yep.
So, and it's what I mentioned at the initial. Like, if you have like some network partition that it's doing their own thing and they have like a runtime upgrade and another one that doesn't, then you essentially have two forks, right? And then when that gets combined together, so like when the network partition resolves and now they are connected, they will talk amongst each other, and then they will decide, okay, that fork is invalid, and we just throw it away and we continue with the other one. And then, because all of those transactions, if they are still valid of the other fork, will also get passed, then maybe it will get upgraded, but probably not. Like, this is like a very edge case. It's quite hard to happen.
Yeah, please.
Yeah, I was wondering, okay, so say if my runtime has multiple dependencies on other palettes, and then there's an upgrade to a palette, causes some erroneous behavior that I'm not responsible for. What are the safeguards to prevent my runtime from like basically adopting that new palette? Like I'm thinking of how in GitHub and continuous integration, you have unit tests, and you can only deploy a new version when all these unit tests pass. Is there anything way for me to like protect my code from perhaps a bug in a dependency I'm using?
Well, this is also like part of the process when we develop any software application, right? It's just like I think in case of Polkadot, at some point, like they essentially make a code freeze. So it's like, okay, from here this will become Polkadot stable number something, and then if they find bugs on something, they will fix on that branch, and then at some point they will say, okay, it's stable enough to go into the main chain.
Okay, I'm just considering a case where it's like I deploy a smart contract, and then some months later, because it relies on a dependency, that dependency updated. Now my users of my smart contract are angry because some bug affected their finances.
Smart contracts are a bit more interesting, but it's a different story as well.
Sure. Okay.
Hi, it's Ben. Do you have any specific examples? Projects, platforms, parachains, some specific example of these cons of a dynamic runtime. Experience the negatives of a dynamic runtime.
Negatives, a negative what?
Yeah, you've highlighted quite a few negatives, like cons of a dynamic runtime. Yeah, but do you have any specific examples of a parachain, a substrate, a protocol, a platform adapt?
I mean, as part of the state migration, we had like the staking migration, and now also we are migrating everything to Asset Hub, and that's even like a more complicated migration because it involves moving something from the relay chain to the parachain. So that's, imagine the state migration there, it's extremely hard. Now, transactions become invalid. There's an example, like this happens all the time, right? If you do a transaction at the same time that the code upgrade is happening, most probably your transaction will happen either before or it will just become invalid. And that controlling more complicated. It's also hard to find a specific example. I'm sorry, but yeah.
Hello, Deepak here. So does upgrading runtime really affect the hardware or not?
Affect?
Yeah, affect the hardware or not?
The hardware, no. Like usually no, right? Like you make a runtime upgrade, and usually it will use that. If you need a new host function, then that needs to use, I don't know, a new cryptographic primitive of like a new hashing function or whatever, then it's what we discussed before, right? You need first to tell everyone, every node operator through the fellowship or whatever, that they have to update. And once you know that at least 60% of the nodes have already upgraded, then you can do that runtime upgrade.
Yeah, I have one question. It worked? Okay. If you can elaborate a bit on the upgradability I'm just like considering a situation where we have some nodes with a runtime that's not compatible with the other nodes runtime. And is there any tools in the ecosystem right now to validate that when I'm making an upgrade doesn't break the ecosystem or the network itself?
No, right? Like we don't have this mechanism. Like you have to know that the runtime is going to update at one specific point.
Yeah,
like
I mean,
have,
let's say I have
Yeah.
a node, and there is like it could be malicious or non-malicious like upgrade,
Yeah.
and I'm upgrading it, and I don't know like there is no compatibility check to make sure I'm not, like
That's a good question. Yeah. The thing is that, so we have actually released a tool from the Puppy team that is actually made for this. So you can compare two runtimes, and it will tell you what are the breaking changes of that thing.
Thank you.
But we did this as a way also of helping that, right? Of helping that process. But it's really hard to tell if what are you going to break, what dApps are you going to break with that? Because every dApp is using their own business logic, and if you have to coordinate with all of them, it's quite hard. It's a nice problem. It's a problem that we have now, so it's really good. Yeah. Yeah. We can continue. So
Yeah, one last one.
Okay.
Very last one. So
It's not a question, maybe it's a point of discussion maybe. So when we like add the advantage that it enables forkless upgrades, so it might like we might like assume that forks are not always good, right? But there might be a different point to look at that if we have that ability to have a fork, then it becomes the community's maybe decision to pick their sites basically and have both of them running. So in Polkadot, when we maybe finalize like the forkless upgrade, so which means that everyone it's like yes or no, so there are like no two paths. So when we finalize this, were there like any such like discussions maybe, or so yeah.
Yeah, no, not really sure. I don't think that, because is it as I said, right? Like these terms of like forkless, it doesn't mean that it just like will prevent the chain from having any fork. It just means that you don't need a hard fork of getting everyone to upgrade at some point to have it happen. It's just part of that. Of course, like if as part of the consensus, you can still have multiple forks and all of that, but at some point it's going to get finality, and finality means that only one chain is the winner. That's all. Okay. So let's continue and talk about the runtime APIs. We have many names for runtime APIs. Sorry for that. Here I put runtime functions, runtime APIs, the same thing. So what I explained before is that runtime APIs are like the face for the node, so the node can call it, right? So this is essentially how it started, right? We have core initialize block. So this is to initialize a new block, then execute block, or apply one specific extrinsic, right? Or validate a transaction, because like the node is receiving a new transaction and it wants to know whether that transaction can be added to the pool. So it calls validate transaction on the runtime so that that transaction gets validated and included and so on. But now what happens is that if you look at the runtime APIs that have been added lately, is that we have a dry run call. We have another one, which is to get the metadata. We have another one, which, for the nomination pools, it transforms the points to the balance. And another one that is for the inflation. It just, it predicts something about the inflation of how it's going and everything, and all of that. So can you see a pattern here? What happened? Right? So what we had before is like something that is specific for the chain, right? It's like the node needs all of these functions. But if you look here, does the node needs to know about what the points to balance of nominator pools API really is? It doesn't, right? Does the node need to know about the inflation? It doesn't. So why do we have this? Why are we adding these ones? Well, the answer is, oh, sorry. Well, no.
Let's say to use in dApps so we can upgrade for some things that we cannot do off chain. So we need like inflation to be calculated from chain and don't do that things off chain.
Yeah, exactly. Right? So this is to cover one pain point that we had with dApps, which is like, well, there's some business logic on chain that is already implemented in Rust, right? And it's there. But now we have to create a dApp in JavaScript, TypeScript, or Dart, I don't know, whatever, that needs to replicate this thing, right? It's like I need to calculate the inflation points and whatnot, right? To show to my user how the inflation is going. So now there's a problem because it could happen that a runtime upgrade changes the way that the inflation is calculated or whatever. And that will go really well for the chain, but then for the dApp, it is now showing not the correct data, right? So what we can do instead is like, well, we can just create a runtime API that essentially the dApp will be able to ask the node to please run this runtime API for me and give me the result. And so this way, dApps essentially can just call all of those, okay? There's now actually a new way, a new sort of like runtime API, which is called the view function. And I think it's related to a question I had before. So in terms, because what happens here is that, well, you can see here that we have nomination pools API point to balance. And this is actually because in Polkadot, we group things by what's called a palette. So we had a palette, which is nomination pools that deals with the nomination pools. But the problem is that palettes didn't have a way of showing these functions to the dApps. So what usually happened is that you had a nomination pools palette, and then you would have to go to the runtime APIs and say, okay, I'm going to create a new runtime API that starts with nomination pools API and so on. So now with a new version of metadata, and we will go through that later. So there's a new way for each one of these specific palettes to say, okay, and I have this function that I'm exposing to others. So the runtime, and we're almost finished here. So the runtime essentially caters to three different actors. So one is the node, is the one that we have discussed, applying extrinsics, handling blocks, etc. Then we have the dApps, and for the dApps, we have these view functions that I have described now, but also we have custom logic. So that metadata, or dry run a call, right? That's not for one specific call, for one specific palette, but imagine that you have a transaction, and as a user, you want to know this transaction, what is the outcome that is going to have? It's going to pass, it's going to, what events will it happen, without actually executing it, because I don't want to spend money on that. So you can dry run that transaction. But then we also have some that are actually valid for both, right? So for instance, like figuring out if a transaction is valid. As a user, I also want to know that, right? Before I submit a transaction, I want to know if that transaction is valid, and same for the fees. So enough talk. Let's deploy a runtime upgrade. So I have prepared a repo. The only thing is that the setup is quite painful. You have to install multiple things. You have to compile Polkadot SDK, and that takes quite a long time. So I have it prepared here, but
can
maybe
you zoom in, please?
Sorry?
Can you zoom in?
Yeah, I'll see. So I have it prepared here, but maybe like if you want to play around or whatever, then you can do on your own at your own pace. So I have also prepared a README with all the steps that you need to take and all of that. So I have a repo here, and this is really cool because it comes from this. So Parity has a repo here called minimal. I'll zoom now. Polkadot SDK minimal template. Okay, so this is essentially, instead of bringing in all of the Polkadot SDK repo, which is like massive, I just want to have like something quick and dirty running. Okay, so Polkadot SDK minimal template is just something that so that you can play around with, and it's way faster to compile and everything. It still takes a while the first time, but it's not as painful as Polkadot SDK. So what I've done here is like I have forked this into another repo, which is I will share the link afterwards. But what this does is brings in the balances palette, because we want to do a runtime upgrade, and instead of like adding a new function or a new palette or whatever, I just want to modify the balances palette. So this is what this fork does here. So you will see in order to run a node, this is all in the README, like don't worry about it. But there's something called an omni node, which is also a node just to hack around and just to try stuff that doesn't have any consensus mechanism, because it just runs by itself. Okay, it just assumes that he's the only one in the whole network, and then I just needed to pass what's called a change spec, which essentially just has, okay, you start from this Genesis block that has this code, and has these balances into that, and then a sudo key. We'll come to that later. And then I do dash dash dev, so it runs in dev mode. And now I have a node running. So if I go to the PAPI console and I say I want to connect to localhost, now I have my node running here. Nice. So we want to do a runtime upgrade. What do we want to upgrade? If I come here, we have the runtime is in here, but the runtime is importing each one of the palettes. So in this, we have like a template, which is empty. It's just like an empty palette for you to try stuff. But here on this fork, I have brought the balances one. So we will go into the balances, and what we can do is find a call. So here we have all of the calls. You see we have transfer allow death. Maybe I'll do like transfer keep alive. This one. And here we have the signature of this function. So this is part of frame. So you will go through this in the protocol track or well, or not. No, in the protocol track you will go through this in detail. But here I will just cover like the basics. So when we have a call, the first argument is the origin. So this is essentially who is calling this specific transaction. Which in this case, we're saying, okay, ensure that this origin is assigned extrinsic of someone. Okay, we have another one, which is ensure root, for instance. So only root can call this method, right? But in this case, it's like, oh, anyone can call it, but it has to be assigned extrinsic. And then it's the arguments of that, right? So we have a destination, in this case, which is an account ID, and a value, which is a balance. And also a bit of a spoiler here, like this is telling that this balance has to be a compact instead of a U180. So what I'm going to do here is add, just as an example, a remark, right? So we have this. So if I go to Polkadot SDK in system lib, no, it's no wait. Where's my? I'm not really sure why I'm not getting this. I'm pretty sure it's not here. Well, my Finder is not working, but in the system palette we have like a remark which does absolutely nothing. It's just like a transaction that you can use just to say something to the blockchain without doing anything. So just we will do this. So in case that I don't know, I want to do like a transfer keep alive that is going to say a concept. We can actually call it a concept. So like a bank transfer concept or whatever. So because I don't want to make this a breaking change, because otherwise my dApps users will be extremely upset with me. What I'm going to say is that, well, this concept is actually optional. So I'm going to do, it's an option of string. So this is a back of U8. And I'm not doing anything with it. You know, it's just like, it will be part of the transaction, so anyone can see the concept, and that's all. So before I make this runtime upgrade, I need to bump the version. Otherwise, I will get the rejection. So I go to lib runtime. And here we have the version constant. So I'm just going to bump. We have the spec version on 0. I'm bumping to 1. And now I can come here and say cargo build. So I'm telling, well, it's split into, I mean, here. Yeah. So I'm saying cargo build the project minimal template in release mode. So with release, I'm building actually a WASM. And when I come here, you know that it's done in target release W build, which comes for WASM build. Then inside WASM build, we have minimal template runtime, which is like the project. And now in here, we have all of these WASMs. Okay, so this is now binary. So I cannot see what's in here. But these are the WASMs that get generated. So also there's like some steps that they are created. So there's like these intermediate steps. The compact compressed WASM, it's usually that's the one that's deployed. The others would work as well, but they are bigger. So there's like a process of making the WASM smaller, and this is the result. So now we can deploy. What I will do here, so here's my thing. I can go to extrinsics, and first we can see. Actually, what I will do is like in two separate things. But in here, I can do balances, transfer.
We need more zoom, Victor. Yeah.
Here. Like
That's
this,
fine.
This is really big, man. So this is my original balances transfer keep alive, and I can do that. And in another tab, I'm going to do a system upgrade. So I can do system set code, but can I do this directly? No, because someone mentioned before, this would be like really dangerous. Like I have to do it as a sudo, like as a root. So we have this sudo palette, but we can say like, I want to call this as sudo. And now only the sudo user will be able to call this, because like this is running omninode, and you know it's just in local. This is fine for this chain. If we go to how? If we go to Polkadot, and I'm going to now, you can see here that if I do sudo, there's no sudo in Polkadot. Okay, so Gavin doesn't have that. But if I go to Paseo, for instance, Paseo relay chain, and I do sudo, so Paseo does have a sudo account. It's just like, what happened here? Well, Paseo is it's a test network, right? So no one is playing with real money here. So this is why they said like, okay, we're gonna have a sudo account here. So in this case, sudo. Oh, this is interesting because I have not added the instructions on how to get the sudo. Well, I'll add them later, but it's simple. Sorry. So I do on my local node sudo system, and then we have set code. And here I can just select my minimal template, compact, compressed, this. So here I have the extrinsic, which is a really big extrinsic. It doesn't even fit in the screen. And I can just submit it. So, okay, I'm not really sure what happened there. So, yeah, to submit it, in this case, the sudo account is Alice. So Alice is a well-known account. Everyone, maybe not, but yeah. So there's like a seed phrase that's really well-known, and everyone just can get their Alice signer from that. Okay. So in this case, I'm just going to sign with Alice and extension here. And now that the transaction has happened, so we can see here it's in the finalize block. So we have the system set code. And as part of the events, I have system code updated. So this has told us that the code has gone through. And if I come here, look, there's a concept here, right? And actually, like this happened live. Like I didn't have to refresh. Like it's a bit of a miss that I didn't like show how this happened live. But anyway, so this DevTools is a tab, right? And this tab is already taking into account that the runtime can upgrade. So it's looking at the runtime, and as soon as the runtime upgrades, it's like, oh, there was a runtime upgrade, so I need to update my UI in order to reflect the new runtime, right? And now we have this concept that, you know, by default selected, but I can say like, no, I don't. Why is it not updating? So I'm doing stuff here, and it's not. I think. Let me see. Oh, I lost my network connection, and I'm trying to reconnect.
It was the stream, so it killed the connection.
No, the internet is down. Whoops. Well, but you saw the effect, right? Like, so it's like we had this runtime upgrade, and the DApp, which is in this case is DevTools, has detected that and has reacted accordingly. Now we have done this like pseudo stuff, but again, like in a real environment, it would go through the process of like not using sudo and just using referenda, fellowship, and all of that. Maybe we can take these technical issues to take a short break. A 10-minute break. I'm not really sure when it's.
Maybe 5, because
5 minutes.
Yeah.
Okay. Yeah, that's good.
We finish at 5. So. Real 5 minutes, guys.
Take it from me. It was too late, too hard to fall. To fantasy. Oh, take it from me. Oh, fantasy. Never let it show. Never let it show. Overthinking every single part about us. Overanalyze our thoughts and all our angles. I can't get it in my head. I can find some good news. So I believe it. All we do is selling more than empty bottles. We're the best at fooling. Once I thought of us as more than hopeless topics. It was only a mirage. Oh my God, wake up. When the ain't you. Oh, well, call me crazy. Spark imagination. You give me so high. So crazy that I can't deny.
Okay, let's continue. So yeah, something I want to do before we take some like questions and so on is I want to show like this tool that I mentioned before, that it's just to see like the breaking changes on all of that. So now I have this, I have done this, but let's do another runtime upgrade, or maybe, well, yeah. I'm going to come here and say like, okay, now it's a version 2. And now I'm going to be evil and on transfer allow death. Instead of making it optional, I'm going to do the remark as a breaking change. So remark, now this is a vec of U8. Or we called it concept. So now I have this one. And what I want to do is this wasn't that I built before. I want to keep it. I don't want to lose it because I will need it to, well, I actually wouldn't need it, but anyway, I can do alt runtime. And now I'll build the new runtime. Here, cargo build. It's building. Okay, so we have this tool over here on div happy how. And I'll do it bigger. Okay, so this tool over here lets you compare two runtimes, any runtime that you want. So we have actually like 3 ways of getting that runtime. You can either through a WebSocket, so you can say like, okay, connect to this specific node and just grab the runtime on the latest block. Or you can also say, I want the runtime at that specific block height or block hash. There's another one, which is like through a metadata, and we'll cover that later. Or you can just like upload the WASM. So what I can actually do is tell it, well, I want the one in localhost. I think it's 9944, and the current runtime. Okay, no, I didn't put it. I didn't put it correctly. I'm not really sure which one is the URL now. So I'll just grab the the old runtime. I'm going to put it here. And now here, I'm going to select the new runtime. So it's in release, build, minimal template, and the new one is this one. So both runtimes loaded correctly. And if I come here, I see what has been changed, right? So I see that nothing has been added. There are no new functions. There are no new, nothing has been removed. But now we have 4 changes. So we have here on balances, we have a transfer allowed depth, and look, it's telling us that it's incompatible, right? And why is it incompatible? Well, because we have added a new property that is mandatory. So every single dApp that is using a transfer allowed depth that is not passing that argument is going to blow up now, because this has been incompatible. If I look at, let me see what's the source here. 44, but it's what socket? Yeah, but it's the same thing. I want to do a specific hash. Hopefully this also works because it's going to be like an old hash. Probably this one didn't have it yet. No. No, SS it's not, because it's WSS is like if it's through a secure environment, but because it's in localhost, I'm not really sure why it's not loading my thing. I have an exception here. Oh, because I'm in diff puppy how probably. I'm not really sure what's going on here. Why it's not connecting to this. What I wanted to show is like if I come here and I do, actually I think if I remove this, it will still be, well, it will be a partial. Let's give this a try 1 second. So I will create a new runtime here. Release, web build, cat. I want to copy that one, and this is with a breaking change. Breaking, and now I can build it again. And now I'm going to compare the old one, old runtime, with this new one, because this new one has both changes, I think. Yeah. So wasn't this one, compare. All right. So yeah, we have now 2 different changes. So we have one, which is transfer allowed depth, which is incompatible, because this is the one that we added this mandatory property. And the other one, which is transfer keep alive, it's marked as backwards compatible. Yes, sorry. Oh, like that. Now, of course, like this backwards compatible, someone could argue like, well, is it really backwards compatible? Because you know, we have removed a property, like we have removed one of the arguments, right? So what happens if someone calls it with an extra argument? Shouldn't it blow up? And this is a good question, but the thing is, this is the puppy diff tool, right? So what this is telling you is that puppy will not blow up in this case. It's just like it's a decision that a library author, someone has to take. And what we have decided for PAPI is that in this case, it will not blow up. Because we value more like, okay, it's still compatible, right? Like a property has been removed, but if you give me this property, it's like, okay, you can give me like 50 properties and I will just ignore them because who cares about them, right? I only care for the properties that the current runtime is asking for me, and the other ones I'm just going to ignore. So it will be backwards compatible. But in the case of transfer allowed there, it's like, oh, I need another argument that you're not giving me. So this is going to blow up. Yeah. Now we also have these ones over here. And why is it telling me that these have been modified if I have not really changed anything on these functions? There's sudo and sudo as. But there's also like this partial thing, which is interesting. So what could that be? Anyone has a guess? Yeah, there's guesses here.
Because sudo partially implements the transfer keep alive.
Exactly. Really, really, very well seen. So the thing is that sudo is a transaction that, as an argument, it takes another transaction, right? So sudo itself has not changed, but the transaction that you can pass to sudo potentially has changed, right? If you did like sudo set code, that didn't change, right? So that was fine. So this is why we have this partial here, because partial means like most of the time it will not be a problem, but it could happen that a DApp is using like sudo of a transaction that now is no longer there. So that will break, but the others will not, right? So how can we know about this? Like, how does this tool work? How it's like, okay, I'm connecting to a chain and there's a runtime and I can get like the code, but the code, well, it's just like a bunch of binary data that I can't even understand. So how does this tool actually work? How is it possible that this tool is able to say like, oh, like, look, on the previous one, we had this function that took 4 arguments, and this one takes now 3. What happened there? Question? No? Ah.
Okay, maybe because of the signature of the function that is stored in code, or the like ABI or something like that.
Indirectly, yes, but it's like this tool is not. It doesn't look at the code. It doesn't go to the code and decodes the code and then extracts the information from the signature and all of that. Like that would be like extremely complex, and we have a much simpler way. So what we have, like if you look at this on the start of here, right? It's like, okay, I want to connect this to the chain. I'm just giving you WASM, but there's another option which is the metadata. And this is actually what is using under the hood. So if it's connecting through a WebSocket, what it will do is connect to that node and call a runtime API called metadata that essentially just brings the metadata. If it's a WASM, what it will do is instantiate the WASM in the browser and then do the same thing of like calling that runtime API to get the metadata from that, right? And then if it's a metadata, then it already has it. So we will go deep into metadata tomorrow as we continue through that. But as a sneak peek, the metadata essentially tells us what is the shape of everything. Like of every single transaction, we have all of the signatures there. So what arguments does it take? What names those arguments have? So when I made this change here of adding this, well, I had here an argument which is like concept. So this is also going to be part of the metadata. That is like this argument is a vec of U8, and its name is concept. So now dapps can actually show that, right? Also, this is how def PAPI works. So if I do balances, transfer all, you can see here that I have like these tags, right? So I have destination and keep alive. And this is also part of the metadata. Yeah? In here, we have a tab, which is called metadata, where you can explore everything that the metadata has. And there's like a JSON format as well. And we will cover like really how does this work and everything. But you can imagine that, yeah, in here we have, all of the palettes, and every palette has these specific storage entries and these calls and these events and these errors. And it's not just the transaction, it's everything in it.
So when you're doing an upgrade, how do you get the permissions to do update code? Like, who decides who gets pseudo permissions?
No, it's just part of the chain, right? Like again, like in this case, like it's an omni node. I have pseudo because it's made so that you can play around. But
what about
on
like
Polkadot, no one has pseudo.
Oh, okay.
Yeah.
Does the metadata take some other things like timestamp, block hash? So if we return the same code as it was previous, will it be the same or will it show as modified?
The metadata is specific for each WASM, essentially. So it doesn't matter the block, it doesn't matter the timestamp, it doesn't, it's not like I pass a new timestamp and now, no, because
So
the
on the
metadata,
code.
yeah, it's just like, okay, this runtime has these interactions and this is how you play with it.
If we had, like before in WASM, we had just one backward compatibility, would it show that is partial again for the pseudo, or it will show it just backward compatible?
It will show backwards compatible. So but this is a question about this tool over here. So the reason this is showing partial is because there's a potential path that will lead into an incompatible, right? But if this was not here, I'm not really sure if I have enough but to try it anyway. But if this was not here, then here it would say backwards compatible, because yeah.
Thank you.
Okay. So I would, sorry? No, if there are more questions, but I didn't see anyone raising their hand. That's fine, right?
So my question was regarding the dry run transaction.
Mhm.
Yeah. So we mentioned that dry run transaction don't cost anything, right?
Connection?
The dry run transactions that we saw like previous to this, the demo.
Yeah.
So those dry whatever like transactions that we dry run to check like how would the transaction like result in. So those transactions don't cost anything, right?
No, like the transactions, they all cost things, but there's like mechanisms so that you don't upload the whole thing. So this is what I mentioned before, that you just like say, okay, I want to authorize this upgrade of like with this hash, and then instead of when I come here, so I have system, like here I did the set code, but this needs sudo, right? So the question is, how do I do this without sudo? Well, so there's first a call, which is called authorize upgrade, but this one doesn't take the code. Sorry. I said I repeated the question in yeah, never mind. So this system authorize upgrade also needs sudo, sorry, but you don't need the whole code. So you can submit this and you will not get stabbed to death with fees, right? Like this will be really cheap to say, and it's like, I'm just authorizing this. And then what you can do is system apply authorized upgrade, and this is actually a permissionless, it's called, a permissionless transaction. So it means that, well, if you want, you can submit, and then you will pay for. The thing is that this wasn't that you see here. Oh, well, it's really small, but it says it's 400 kilobytes, which is, oh, this is really big. No, if you look at the WASM of Polkadot, it's much bigger. So you're going to pay like a transaction for really big, but this is permissionless. So it means that anyone can do this. So it means that I can actually come here and say submit without signing. So this will submit the transaction and it will fail because it's telling me that the transaction, well, the transaction is not valid because this specific code was not authorized yet. So first, someone has to do the authorize upgrade of like this specific thing, and then this is anyone can do this, so it's done through an unsigned extrinsic.
Hello. Yeah.
Yes.
Yeah, I just had a quick question. So I was just curious. So for like a runtime WASM that's like a release candidate for an upgrade, is there like a mechanism for adding some kind of like embedded metadata with like provenance information that kind of allows you to like trace it back to like a specific commit hash and like parity, your specific Git repository to like basically trace it back? You know what I'm saying?
No, you said something about a malicious something, or?
Oh, well, I was curious about like provenance information. Like GitHub has a system for provenance where you could trace, a specific build back to a specific commit hash.
There's no. Well, in the metadata, there's a field called docs where you can add some documentation for specific interactions, which is also, if I come to storage here, this is also showing. So you see, like, system account has these specific docs, the full account information for a particular account ID. So here you can put like whatever you want. If you want to put like a Git hash, then sure, but it's not the purpose for that. Yeah. Like this is just docs for specific entries of the runtime. Which, if you think about it, this also means that this string is actually part of the runtime. It's anything that is inside the metadata is inside the runtime. So these docs are in the code, like because the runtime is able to generate this metadata for us.
Oh, hello. Yeah. Yes. So like coming back to the transaction question. So like that didn't answer my question. So my question, I'll maybe like rephrase it. So I'm talking specifically about the runtime functions. Yeah. So in runtime functions, we had a dry run API, right? To make a dry run call to like exactly understand what the transaction results in. So my question was, does that dry run?
Yeah. Like in this case, you see, like we have multiple names for runtime APIs. We have runtime APIs, runtime functions, or runtime calls. Sorry for that.
Yeah,
but in the case of runtime calls, like these calls are completely free. So here I'm doing like, I don't know, core version, and it's coming back like the runtime with some information, and I did it for free. I didn't have to pay anything. I didn't pay any transaction. So actually, I can also show here. There's a metadata, and I call it, and you see here I get like a bunch of, binary data that we will see tomorrow how this makes any sense at all. But here we also have like the other ones, right? So transaction payment API, I can do query info, and then I pass in a transaction and the length of this transaction. This is an implementational detail, and I call this, and it will give me the fees for this transaction and all of that. So, and all of this is free. I can just do it, and yeah, because like this doesn't take a toll on the network, right? The only one that is actually running this function is the node that you are connected to. Like no one else is running it. So this is why they say like, okay, it's free. Then the node operators can say like, oh, if you're doing too much stuff, then you have to pay us. So I'm just closing your connection because I don't want you to spam me. But it will not take the network down.
Okay. Yeah.
I think, yeah, let's do just one last question, and then we're done because, yeah.
So when we are upgrading the runtime, is there a scenario where I want to change the way data was stored earlier, but then before upgrading the runtime, I want to modify how the data was stored or processed and then apply the runtime upgrade? Is there a scenario for that? If yes, how do I specify that?
I'm not sure if I understood the question correctly, but what I understood is if there's a runtime upgrade that changes how the data is being encoded or decoded, of like a transaction, I don't know,
I can give an example. So host functions, for example,
Yeah.
I'm assuming that every node would have some data about the node itself, which comes through the host functions. And if I want to apply a runtime upgrade, but before that, I want to change the way host functions deliver the data.
This is what we said before. Like, if you have to do some change on the host function, there's no other way of like telling everyone, hey, you have to update your node. And then you have to wait before, like, before doing a runtime upgrade, you have to wait until everyone has updated their node before that can.
Okay, and how do I specify in what way the data should change, which was stored in the node earlier?
It's through a fellowship, right? So this cannot be on chain. This is not something that can be specified on chain. You have to do it off chain. You have to talk with everyone and say like, hey, I want to do this thing. So this is also what Joseph mentioned before, is that it's not really like, oh, I want to do this and I'm just going to do it because whatever, and I will talk with my friend. It's like there's an RFC process that first you create an RFC and you explain, okay, I need to do this change to the protocol. And the RFC comes for request for comments, which is just like, please let me know what you think. And there's a discussion with all of the community that is like, oh, like, is this change actually a valid one? And there's a bit of discussion there. And if it's appropriate, then it actually gets implemented in the node, right?
So it's part of the runtime upgrade code itself.
Yeah. But if you think about this RFC, it's not on chain. This is also happening off chain, and is the way that we have to communicate amongst ourselves. Yeah, so we just like 10 minutes left, but I don't have, like, I could start the metadata, but I think it's better to just start tomorrow into a new thing.